Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss the next topic from the chapter is matter around us pure. The title of this topic is separate separation of components of mixture. It belongs to the chapter is matter around us pure. Okay, this is the title of the chapter and the topic name is separating components of mixture. Components of mixture. Before that, let us have the quick recap of the previous chapter, or what is left for the previous chapter that we are going to first of all discuss. If you remember, we have discussed about the suspension and colloidal solution in the last class. Suspension examples and everything I have discussed with you already. Just a minute. Yes, some examples of colloidal solution are left that we are going to discuss first of all, and then we will start with the separating components of mixture. Okay, so examples of colloidal solutions, common examples of colloidal solutions. Okay, let us see. So as I have told you, in case of colloidal solution, we are not calling it as a solute or solvent. Instead of that, we are using another terminologies, dispersed phase and dispersion medium. Okay, yes, let me write down the types first of all, so one by one. So dispersed phase and dispersion medium. Only representative examples we will see. Dispersed phase and dispersion medium, type of the colloidal solution and examples. Okay, let us see. First example of colloidal solution in which dispersed phase is liquid and dispersion medium is gas. Such a type of colloidal solution is called as aerosol. Okay, sol stands for solvent, aero stands for gas. Okay, so in this colloidal solution, the solvent is air. Okay, examples are fog and clouds. Okay, yes, the next example we can discuss, in which dispersed phase is solid and medium is gas. This is also called as again aerosol, because solvent is air or the dispersion medium is air. So here the example is smoke. Then we will see the next example, in which dispersed phase is gas and medium is liquid. So this is called as foam, and the example is shaving cream. Shaving cream. Okay, the next example, next type, in which the phase is liquid and medium is also liquid, both of them are liquid. Such a type of colloidal solution is called as emulsion. Okay, both of them liquid. Example is milk and face cream. Okay, milk and face cream. The next example, in which the phase is solid and medium is liquid. Phase is solid, medium is liquid. Such a type of sol is only called as sol, only sol. Okay, and examples are mud and milk of magnesia. Mud and milk of magnesia. Okay, yes, the next type, in which the dispersed phase is gas medium is solid. Okay, this is called as also foam. Example is foam and rubber. Foam, rubber and sponge also. These are the examples of foam. Okay, the next, in which this first phase is liquid and medium is solid. It is called a gel. Okay, examples are jelly, cheese and butter. Okay, and then the last type, in which both of them are solid. It is called a solid sol. It is called a solid sol. Examples are milky glass and colored gemstone. Okay, so these are some popular examples of the colloidal solution. You can take a screenshot of this page first of all. Okay, yes, now that's what about the colloidal solution. I hope you have taken a screenshot. After that, now let us start separating the components of mixture. Separating the components of a mixture. Okay, for this purpose variety of methods are used, like evaporation, decantation, condensation, distillation, etc. But we are going to discuss them one by one with the help of examples. Okay, so first example we will see separation of colored component, that is dye, colored component, that is dye from blue or black colored ink. You know, the ink which we use, it is nothing but a mixture of the colored component, that is the dye, which is the organic compound, and the water, right? So that is the mixture, right? It contains the two components, one in which the dye, that is colored component, is there, and water, right? So dye is nothing but the solute here, and water is nothing but the solvent here, right? So we are going to separate these two things from each other, right? How to do that? It is very easy. Simple experiment we are going to perform for this. So for that purpose we are going to take a beaker. So this is a beaker. This beaker, we are going to fill water in it. Okay, so this is the beaker and it contains water. Okay, now above this beaker we are going to put a petri dish or a watch glass. Okay, above this we are going to put a petri dish or a watch glass, like this. Exactly above this we are going to put this petri dish or a watch glass, right? So inside this watch glass, okay, so this is nothing but the petri plate, or you can even take the watch glass, in which we are going to fill that dark blue colored component or ink, right? Okay, so this is the ink present in it, right? It contains water and we are going to start heating. Okay, so this is nothing but the ink contains dye plus water, right? It contains dye plus water, right? And now this we are going to put on a tripod stand. Okay, so this will be the wire gauze and we are going to put it on the tripod stand like this. Okay, and then we are going to put a burner. Okay, so what is this? This is nothing but the burner. Usually the Bunsen burner is used for such a type of experiments. Okay, and this is toward the gas or LPG, liquefied petroleum gas, right? Okay, so this is the setup which we are going to use for separation of the components of ink. Ink contains water as well as the chemical or that dye which is present here. So what happens after some time? We will start heating. So after heating, this water will start boiling, right? After heating, this water will start boiling, and due to which the vapors will go up like this. Due to the hot vapors, this watch glass also will start becoming hot, right? This watch glass also will start becoming hot, but the temperature which is here inside the water and here on that watch glass will be different, right? Because here we are actually heating this and here we are only heating it by using the vapors, right? Okay, so at this low temperature, right? So here it will be, temperature will be, okay, temperature is lesser than boiling point. Okay, BP stands for boiling point. Here what is the temperature? Temperature is exactly equal to boiling point of water, right? So here boiling will take place, right? Here boiling will take place, right? In the beaker what will take place? Boiling will take place. But what about the this portion? Here the temperature is not that much high, right? It is less than the boiling point temperature. So here boiling will take place inside the beaker, right? But what will take place here? Here the evaporation will take place, right? As we have seen the definition for evaporation, it is the conversion of liquid state into the gaseous state at lesser temperature or at temperature lesser than the boiling point of the substance, right? Therefore what will happen after some time? You can see the vapors of water going up, right? So these are nothing but the water vapors. Okay, yes. So when you start boiling, the water present is inside the beaker. So after some time evaporation of the water inside the ink will take place and you can see the water vapors going up. Okay, so this is how, what will happen after some time, like slowly all the water in the ink will go up. Slowly all the water present inside the ink will get evaporated. Complete evaporation take place, and after a certain time or after a certain stage you can observe there are no any vapors coming out from the watch glass, right, from the ink. That means after some time, after heating for some time, only ink is remaining in the watch glass, but the water is not present. Now you can just collect that ink from the watch glass very easily. So this is how we are going to separate the component, that is colored component, which is the organic substance usually, and which is a dye, from the black or blue ink, right? It was very interesting experiment, right? You can try this experiment at home as well, under the supervision of your parents. So just take a screenshot of this page first of all, and then we will move to the next part. Okay, I hope it's done. Now let us see the next example. After the ink, the next example. Second example. Separation of cream from milk. Okay, this is done by centrifugation. Okay, so simple experiment. You can perform this experiment in your school where the centrifuge machine is available. So centrifuge machine is very easy. So what is there? So there is such a type of stable rod which is fixed to some surface. Okay, then this rod is having this kind of disc which is able to move. in all directions. Then this will have some holes, like few holes here, and then we are able to connect or tie the test tubes to these holes, right? For example, this is one test tube, second test tube, third test tube, fourth and fifth, right? And this is connected to electric circuit. So when we start switch the button of the centrifuge machine, so this is the centrifuge machine for an example, or which is also called a centrifuge, it will start rotating very fast, very fast. Okay, it will start rotating very fast in one direction, circular motion. Due to very fast rotation, like you can say 1000 rpm per minute, 1000 rpm rotations per minute, what will happen if this is the test tube, right? I'll draw the separate diagram for test tube also. If this is the test tube, okay, and this is the test, just a minute, for example, this is the test tube, okay, this is the test tube before centrifuge, okay, this is the test tube before the centrifuge. So before the centrifuge, I'll show the milk by yellow color. It's not yellow color, but white will not be visible, so I'll show it by yellow color. So this is the centrifuge, okay, like this, okay. Yes, so before centrifuge, this is the scenario. Then what will be the after centrifuge? Let me show you. Again, this is the test tube, and after centrifuge, what will happen? Some portion of the milk, which is nothing but the cream, it will be settled down like this. It will be settled down, and the clear portion or the little bit transparent portion, that will be above that, okay. Yes, so here this portion which is separated from the liquid part is nothing but the cream, okay, and this is nothing but the super liquid, okay, upper part, okay. So this is how we are able to separate the cream from the milk by the method called as centrifuge. This method you can perform by using the machine, centrifuge machine only. You cannot perform this experiment without the centrifuge machine, right? Then how to separate the milk without the this machine at home? For that purpose, you can simply use the churning machine which we use in kitchen to separate the milk from the cream from the milk, okay. Yes, take the screenshot of this page also. Okay, yes, then let us see the next example. The third example. Okay, before that, let me just tell you some other applications of this centrifuge machine. Or centrifugation, out of which few of them you might have observed or seen. Okay, let us see one by one what are the application. The first application in pathology laboratories, which are also called as diagnostic laboratories, for testing or for blood and urine test. Because some components of the blood or urine, they need to separate from the whole mixture, and therefore in laboratories, first of all, it is centrifuged and then some tests are performed. Okay, then second, used in dairies and home. Used in dairies and home to separate butter from cream. Then next, third application, used in washing machines. To squeeze out water. To squeeze out water from wet clothes. Water from wet clothes. So these are the applications of the centrifugation technique. Okay, yes, then you can just take a screenshot of this page. Till then I'll write down the third example. Third example is separation of two immiscible liquids. Two immiscible liquids from a mixture. Okay, so what is the meaning of this word immiscible? So when we are talking about the liquid substances, in that case, instead of using soluble, we are using the word miscible, right? For example, if I am talking about the solid solute, okay, solid solute and liquid solvent, right? Solid solute and liquid solvent. Just a minute. Solid solute plus liquid solvent. Okay, and another case is liquid solute plus liquid solvent. Okay, now in these two cases we are using the different words for solubility. Okay, like if it is soluble, then we will use the word soluble. If it is insoluble, we will use the word insoluble, right? You know the meaning of soluble and insoluble, we have seen it already. But in case of the liquid solute and liquid solvent, instead of soluble, we are going to use the word miscible, and for this we are going to use the word immiscible. Okay, immiscible means not soluble. Okay, Yes, so when such a type of solutions are there, or such a type of mixtures are there, how to separate them from each other, that part we are going to discuss now. Okay, for that purpose one simple assembly we are going to use, that is called as the separating funnel. Okay, yes, let me just draw the structure of separating funnel first of all. Okay, so this is the separating funnel. I'll name the parts later on. Okay, so this is the separating funnel. So let me just write down the title. This separating funnel is used to separate the immiscible liquids, right? Yes, so let me just write down, this is the separating funnel. Separating funnel. This is a separating funnel. Separating funnel. Let us see what are the different parts. So first of all, this is the stopper for separating funnel. Okay, this is the core by which we can open or close the separating funnel, and this is the separating funnel, right? Okay, in which we are going to fill the immiscible liquid. Right now, in case of immiscible liquid, there are different portions are there, or what you can say. For example, here, if this immiscible liquid has these two parts, okay. For example, it has this yellow portion or yellow liquid, okay, which is here. Okay, yellow liquid is there, and it also has the another component which is of different color. Okay, one part is yellow, another is, say for an example, this pink. Okay, so this pink part is up to this. Okay, so these are the two components present in case of the this solution, immiscible solution, right? Okay, yes. Now we need to separate them. They are immiscible, therefore they are not what you can say, mixed into each other, right? So I'll write down, this is nothing but, okay, whatever it is filled inside this funnel, it is the immiscible mixture. Immiscible mixture. Immiscible mixture will contain both the liquid solute plus liquid solvent, right? Liquid solute plus liquid solvent, both of them are liquid, right? Okay, so what we are going to do, first of all, we are going to fill this mixture in the separating funnel. Then we are going to close the stopper as well as the core, and we are going to very thoroughly mix the contents of this liquid. Okay, and then we are going to allow it to settle for some time. After some time, what will happen? They will separate into two layers because they are not miscible, they are immiscible. Lower layer and upper layer, right? So this lower layer will be of low density, that's why it is below. Sorry, it is of high density, and that's why it is below. And an upper will be of lower density, so it is floating, right? It is floating, just like oil floats on the water. So this is yellow layer is of high density. I'll write it by using another color. It is yellow color is not visible here. So this is the component of high density liquid, and this is the component of low density, right? And that's why they are at different level. So what I will do, I will first of all collect the liquid yellow, okay, by opening the cork very slowly and collecting the yellow liquid drop by drop in a container, right? When all liquid is down, then after that what I will do, I will change the beaker and I will collect the pink colored liquid, right? So this is how we are able to separate the components from the separating funnel from the immiscible liquid, right? Okay, just take a screenshot of this page. This is the separating funnel. Take a screenshot of this page. Okay, I hope it is done, and that's all for today. In the tomorrow's class we will discuss the next example for the separation. Okay, and then finally I'll show you how to upload the DPPs on the portal. So you will be able to see the DPPs on the resources, and in the writing material you will be able to see the DPPs like this, and you can download it by clicking on it. You will be able to see the questions. You are going to solve them on your notebook and take a picture and upload it here, and then I will be able to review it. Okay, so that's all for today. Thank you so much, students, and take care, and have a great day. Bye.